Welcome. In this video, we'll be taking a look at how to simplify quotients of expressions involving exponents. So to begin, let's start with an example with numbers. So what we have here is 2 to the third times 3 to the second divided by 2 to the first times 3 to the fifth. So what we're going to do is try to simplify this the long way and then see if we can develop a shortcut. So if I wrote out what 2 to the third actually means, well, again, that means I have 3 factors of 2. 3 squared means I have 2 factors of 3. And then on the bottom, what we've got is 2 to the first, which is 1 factor of 2, and then 3 to the fifth is 5 factors of 3. And so now notice that on top I'm multiplying by 2, but then eventually I'm going to be dividing by 2. Well, 2 divided by 2, those guys cancel each other out and make 1s. So this guy becomes a 1 and this guy becomes a 1. Okay, likewise, 3 divided by 3 is also going to make 1. And then finally I have another 3 divided by 3, which is also going to make 1. So what's left over? Well, what's left over is, looks like I have 2 2's on top, which is 2 to the second. And on the bottom, it looks like I have 3 to the third. Now what I haven't accounted for are the 1's, but 1 times anything is just going to give me that thing. So I really don't need to incorporate those in my answer. So my final answer is 2 to the second over 3 to the third. So looking just at the 2's, I started with 2 to the third over 2 to the first. Can you see how a shortcut for how I would have gotten 2 to the second? Likewise, I had 3 to the second over 3 to the fifth, and I ended up with 3 to the third on the bottom. Can you see how, just by looking at the exponents, how I could have gotten 3 to the third without writing it all out? Well, actually, it's a subtraction process. So whenever I'm dividing like bases, the shortcut is I can subtract the exponents. So if there were more factors of 2 on the top than on the bottom, I'm going to subtract 3 minus 1, which leaves me 2 factors of 2 on top. If there are more factors of 3 on the bottom than there are on the top, I'm going to start with 5 minus 2, which gives me 3 to the third on the bottom. So wherever there are more factors of, is where you're going to end up with leftovers. So if you have more factors on top, you're going to end up with leftovers on top. If you have more factors on the bottom, you're going to have leftovers on the bottom. So we've already talked about a number of rules of exponents. And I'm going to add one more, which is if you're dividing by like bases, the shortcut is that we can subtract exponents. And again, in this case, since we have more factors of x on the top, I know that what I'm going to end up with is just x's on top. All the x's on the bottom are going to cancel out. And so if I simplify this, x to the 4 minus 2 is just x to the second, and I don't even need to write the over 1, because anything over 1 is that thing. So let's take a look and see how we can apply that. So if we look at number 1, well, first thing I see are factors of y on top and factors of y on the bottom. But I definitely have more factors of y on the bottom than I have on top. So then I know that I'm going to end up with factors of y on the bottom. So to figure out how many, I subtract the exponents. So I'm going to do 6 minus 5. And then for the x's, I've got more factors of x on the top than I have on the bottom. And remember, it's always a good habit when you're working with exponents to never leave a variable naked. So always write the exponent if none is written. So again, what I'm going to end up with then are x's on the top, and to determine how many, I'm going to subtract the exponents. So my final answer in this case is going to be x to the second on top, and on the bottom I'll have y to the first. Okay, and I don't really need to write y to the first, so my final answer, if I were inputting it into Alex, would just be x squared over y. Alright, I want you to try number 2. Pause the video and then restart it after you've given it a try. So for number 2, it's the same story. So let's start with the z factors. I have more factors of z on the bottom than I have on top. So I know I'm going to be left with factors of z on the bottom. And to figure out how many, I subtract the exponents. The y's, again, I don't want to leave this y naked, so its exponent is 1, which means I have more factors of y on top than I have on the bottom, which is going to leave me with y's on top. And so my final answer is going to be y to the 5th over z to the 1st, which again, I do not need to write the exponent of 1,